The common thread that ties together pretty much every question on page 27 is the notion that it requires a U sub. It's going to be up to you, pun intended, to figure out which method from the previous page better suits you. Whether you're going to choose to convert all of the terms from X to U, or whether you're going to temporarily U sub the problem, switch it back to terms of X at the end, and then just use the original X coordinates to do your evaluating. Personally, while I certainly am equal opportunity to both methods, I find myself using the first strategy, just converting the whole problem to terms of U. I don't know why exactly, it's just a personal preference. I feel like for me that's just more consistent, and then I don't have to remember to pay attention to my variables later on in the problem, and prevents me from making silly little mistakes like accidentally plugging in a X coordinate into a U variable, stuff like that. You may not fall privy to the same uh, downfalls as me. So, in theory, you can do it whichever way you want. But you'll notice that just for clarity, I like to do all of my examples with full conversion to terms of U, and you'll have to bear with me. If you want to do it a different way, you're certainly welcome to, and our answer should be the same. But it's worth noting that that's the way I'll do my examples, and apologies ahead of time if that doesn't really match your preferred style. So I highlighted the or the problem numbers that I indicated on our learning plan for the week that I thought were most essential. That's not to say that you shouldn't do every problem if you have the time, but if your time is limited or if you just don't feel like you really need to do every example as usual, then I didn't highlight certain problems either because they were just kind of duplicates of other questions we've already done. Like letter A is clearly a duplicate of the problem on page 26, just with different limits. Or it's a problem that I don't necessarily find as interesting. So I tried to pick some that either kind of looked like the quiz that we took or would represent AP style questions that I've definitely seen on multiple College Board released materials. I'll start with question letter B, and I'll do a couple of other examples as well, although you're certainly not obligated to watch those. Remember, you can watch any examples that you want to, and of course, use the answer key to help fill in any gaps if you want to just kind of forge ahead on your own. So in letter B, the first thing I want to do is delineate where my side work versus my actual workspace is going to be, because you can see that this sort of separation is really crucial now that we're doing more than just a U sub. Now that we're also converting the problem from X to U, you'll need a little bit more space to work with than you had for previous U subs. Organizing your work is really crucial here. And I have noticed that in both AP settings and in college, professors are pretty picky about making sure that you have a neatly organized workspace. It doesn't have to have a vertical line. This is just something that I like to do stylistically, but it certainly helps kind of visually separate what you're calling scratch work from what you're actually paying attention to with full notation and all the proper details that an integral requires. So the first thing that we'll do is our traditional U sub, because that kind of gets the ball rolling. And we need to define an equation for U so that I have something to plug the -1 and the 1 into. So even though it's tempting to try to do the easy stuff first, I can't do that part until I first choose a U sub. In the order of things, I need to first choose a U sub, then set up the basic substitutions, including the conversion from X coordinates to U coordinates. Then I'll do my antiderivative, then I'll plug in at the very end. So we'll start with the U sub. As you're probably pretty well conditioned to notice at this point, this has a chain rule as part of its setup. It also has a product, but not coincidentally, the derivative of the inside of the chain is going to be 3x squared, which happens to be the thing right outside. So you can tell that our general rule of thumb, go for whatever's inside of the square root or inside of the chain, is still a good way of choosing our U. So we'll start with defining our U. U is going to be x cubed plus 1. And just because I like to do things in the same order as I always do, I'm going to kind of take that next step to just get the ball rolling on my substitutions. I'm not going to write any integral limits at this point because I haven't yet done the conversion. So I'm just going to leave the integral a little bit nude at the moment. Inappropriate, but definitely a good idea so that you don't have to keep writing numbers and then switching them, because that's just going to get confusing. So I know that I'm going to end up moving this 3x squared over with the dx. So I'm just going to kind of mentally rewrite this in a different order than the original problem anyway. I know I have the square root of u, which is u to the 1/2. Since we're going to do a power rule, might as well just take that step now. And then I have the 3x squared dx that I know should get taken care of from my du substitution. So back to my side work for a second. I have du equals 3x squared dx for the derivative. Sure enough, that's exactly what I needed for my substitution. I don't even have to move the constant, which is really, really convenient. So in terms of substitutions now, I have u to the 1/2. 3x squared dx replaces with du. And it looks like we're in pretty good shape. I just need my limits. Now that the problem is in terms of u, I'm going to go to my side work and quickly convert both of my original coordinates to u coordinates so that I can finish the job. So just underneath my original u sub is usually where I do my converting. And it doesn't have to look a specific way. There's no real protocol for notation or anything for this. So you can just kind of show it however you want. I like to generally just write the original x coordinate and then an arrow, because that kind of has a sense of motion or movement to me, like I'm moving from x to u. But you can do whatever you'd like. Now, of course, if x equals -1, I need to find its corresponding u coordinate. So if x is -1, I'll plug -1 in to the u equation that I defined. That's really where the conversion is going to happen. It's the u equation that we already defined. So if x is -1, then I'm going to plug in to the u equation. So I'll do a little highlight there just so we can kind of see that's where I was going with this. And then I'll make that conversion happen. So -1 plugs in for x, -1 cubed is -1, plus 1 is 0. So I know that the new lower limit is going to be 0. By the way, it is pretty literal. The lower limit converts to the lower limit and the upper limit converts to the upper limit, so there's no real surprise there. I'll do the same thing for the other x coordinate. The other x coordinate was +1. So I'll now take +1, and again, I will plug that in to my original x equation, or my original u equation. Sorry, confusing. So if I plug in 1 into that equation, 1 cubed is 1 plus 1 is 2. So its converted u coordinate is 2. And now I know the new upper limit. So now I have a full problem on the right-hand side in terms of u. It has u coordinates, it has an antiderivative in terms of u, it has an implicit du, everything is consistent. Now I have the green light in order to do the actual proper calculus. So if I do my normal routine here, that would be the power rule. So +1 would give us 3/2, do the coefficient, so that means we have 2/3 u to the 3/2 for our antiderivative. That was just the power rule. Evaluated at 2 and 0. Don't forget, we do need to just eschew the plus c, but we have to do the evaluated bar with the 2 and the 0. Now, of course, we just need to try to plug in this whole thing. This is not the prettiest problem to have to deal with, unfortunately, so we might want to just kind of leave it in a relatively uncleaned up state, since there's not really a whole lot that you'd be expected to clean up, especially if this problem, like most problems on this page, is expected to be done without a calculator, which, for the record, is pretty much expected for most of these. Most of these you should be able to do without a calculator. So I'll just plug in and just kind of do the best I can with what I've got, figuring it's not pretty, but I'll deal. I have 2/3 times 2 to the 3/2 minus 2/3 times 0 to the 3/2. Fortunately, 0 to the 3/2, that's going to be easy. 0 to the anything power is going to be 0. But this little madness is not so simple, so you have two choices. Honestly, the path of least resistance is to just leave it as 2/3 times 2 to the 3/2. There's honestly nothing wrong with that. If you wanted to get a little bit fancier, you could try to convert that into something that has like an actual radical symbol. So it would be the square root of 2 cubed. And if you wanted to go even further than that, the most likely answer that you would see in a simplified form is 2/3 root 8. Figuring that 2 cubed is 8, but the square root of 8 can't really do anything. And there's not really much beyond that that you would even want to bother with. I mean, you can simplify the square root of 8, but we're kind of at the point where we know it's going to be a kind of ugly answer. So any of these three versions of things is generally fine. Honestly, it doesn't matter which one you leave with a box around it. They're all completely equivalent. Chances are, if it was an FRQ, we would just leave it as the first answer. If it was multiple choice, I suppose there's a chance they would have presented us with this last possibility, but again, it's your discretion. It doesn't really matter to me. And for the sake of packet purposes, I would say don't worry too much about the cleanup. That should be like your last concern right now. The primary concern, your biggest job, is to just make sure you kind of understand the big picture, converting the problems to you, plugging in the necessary coordinates, and evaluating to get an answer in any form. Now that you've tried letter B, there are a couple of good ones that I think you can try that are similar. Now, they're all obviously a little bit different in structure. The one most like letter B is letter F because of the square root, and I didn't really highlight that one specifically, but I do think that if you can do this one with the square root, you can do virtually any of the other ones. In a subsequent video, you will be able to follow along with another one of the exponential log type problems and a trigonometry problem. But if you feel like you're ambitious enough to try one on your own, you can try any of the highlighted problems at this point just to kind of see how it goes.